Hi all, welcome back to yet another video of the video series Measurements and Instrumentation. In this video we will be discussing about the static and dynamic characteristics of a measuring system. So as the name implies, what is meant by static? So static means the at rest conditions. So first we have any measuring instrument will have a static characteristics as well as dynamic characteristics. So now we will see what are the static characteristics of a measuring instruments. So static characteristics are the characteristics involved in measurement of quantity that are either constant or slowly varies with respect to time. So those static characteristics are accuracy, drift, dead zone, static error, sensitivity, and reproducibility. So the major static characteristics are static correction, scale range, scale span, noise, dead time, hysteresis, linearity. So these are starting from accuracy till linearity. These are the various terminologies or the static characteristics of a measuring instruments. So let's see one by one in a detailed manner. First, let's see what is meant by accuracy. This term is very common to everyone. We are using in a day-to-day basis. With respect to instrument, accuracy, it is the closeness with an instrument reading approaches the true value of a quantity being measured. As the name implies, accuracy, how it is a measure of how an instrument gives the accurate result with respect to the true value. As we know, no instrument is 100% efficient. At least it has to give a value close to the true value. That value is called as that measure is called as accuracy. Now we'll see what is meant by true value. True value of a quantity may be defined as the average of an infinite number of measured values. So you are conducting an experiment and you are repeating it the same for infinite times, and if you take an average of those infinite values, then you will get the true value, or you get the actual measured quantity, which is sometimes tough to get, but in most cases the accurate value will be taken as the true value. Now let's see what is meant by sensitivity. It is the ratio of magnitude of the output response to the input response. Any minor change in the input, it should be replicated in the output also. If that is the case, then it means that the measuring device is so sensitive to all the input variations. That ratio is called as sensitivity. Now, static error. It is defined as the difference between the measured value and the true value. So the true value is the actual value of any measured measurand, and the measured value is the value with some slight deviations from the true value. So let the true value be AT and the measured value be AM. The difference AM minus AT or AT minus AM. This is called as static error. It is also called as the absolute static error. Next, scale range. Scale range for an instrument is defined as the difference between the largest and the smallest reading of an instrument. For example, if you see an ammeter, if you see a milliammeter, the range of the ammeter scale that you see in the dial will be from 0 to, if it is a 500 milliamps ammeter means the reading will be from 0 to 500 milliamps. So that is the scale range. So the difference between the largest and the smallest reading of an instrument is called the scale range. So the deflections, a ammeter can read 0 as well as 500. So that is called as scale range. Suppose the highest point of calibration X max, let it be X max, while the lowest point be the X minimum. Then the instrument scale ranges X minimum to X maximum, just like the case 0 to 500 milliamps. Now let's see what is meant by scale pan. Scale pan means the difference of the maximum limit to the minimum limit, which is in case of an ammeter 500 milliamps ammeter means 500 minus 0. This is the scale span. Now let us see what is meant by reproducibility. This is a very important term in the static characteristics. Reproducibility, as the name implies, any instrument which is capable of reproducing or repeating the same reading over a given period of time is known as reproducibility. So the scale readings over a given period of time, if it is reproducible by an instrument, then it is called as reproducibility. Let us see what is meant by drift. Drift is an undesirable quantity, which is mean as the name implies, drift. So there is a change, an elevation from the value. It is an undesirable quantity in industrial instruments because it is rarely apparent and cannot be maintained. Certain times the drift will cause us a change in the measured value. A drift is classified as zero drift, span drift or sensitivity drift, and zonal drift. Now let's see what are the dynamic characteristics of measuring systems. So the dynamic characteristics include speed of response, measuring lag, fidelity, dynamic error, etc. So speed of response, as it is a dynamic characteristics, the first and foremost characteristics is the speed of response, because as the name implies, the input will vary dynamically, it varies with respect to time. Hence speed of response becomes a predominant characteristics for a dynamic characteristics. It is defined as the rapidity with which a measuring system responds to a change in the measured quantity. So whatever changes, even it is minute change in input, it should be immediately replicated in the output. That speed is called as speed of response. It is one of the dynamic characteristics of any measuring instrument. Let's see what is meant by fidelity. It is defined as the degree to which a measurement system indicates the changes in measured quantity without any dynamic error. So whatever changes in the input, it should be replicated in the output exactly the same without any changes in the measured quantity. So whatever change, minute change, and that minute variation has to be the corresponding minute variation has to be replicated in the output side. So this fidelity and reproducibility is somewhat similar, but the thing is that the fidelity means the fidel ratio should not contain any dynamic error. So let's see what is meant by dynamic error. It is the difference between the true value of the quantity changing with time and the value indicated by the measurement system if no static error is assumed. So dynamic error means just like static error, it is the difference between the true value and the actual measured value, provided the static error should be assumed as 0. It is also called as measurement error. Next is measuring lag. So measuring lag means it is the retardation delay in the response of a measurement system to the changes in the measured quantity. So if the changes in the input, if it is not replicated or it is replicated in a later manner, then it is called as measuring lag. Retardation type means the response begins immediately after a change in measured quantity has occurred, means it is retardation type. If the response of a measuring system is delayed, then it is called as time delay. So these are the basic or the important static and dynamic characteristics of measuring instruments. So hope you have now got the terminologies well well in advance, so that these terminologies will be used then and there in the subject. Hope you got a clear cut idea about these topics. So thank you for listening. Let's see in the next video with a continuation topic. Thank you.